So the coefficient of friction between the block and the plane as shown in the figure 2. What force is needed to maintain equilibrium? So the block here is 60 kilonewton. So to get the FPD, we need to write FPD. And 60 kilonewton. We have 100 millimeter and then 200 millimeter. So to avoid sliding, we have we have P equals to F mu N, which are natural friction, and we have in a given mu is equal to 0.4 and Rn is equals to weight, which is 60 kilonewton. So 0.4 times 60 kilonewton is equals to 0.4 times 60, 24 kilonewton. And to avoid overturning the A, our equation will be MA is equals to 0, which is P is equals to 200 here, 200, and then is equals to 60, which is our weight or natural friction, times 50 here, 50. So we have Rp is equals to 15 kilonewton. This is our final answer for question number 1. This is our final answer. Okay, so for the next is as shown in figure 3, determine the value of alpha to maintain the equilibrium of the system. So it is the given, this is the figure. So we're going to write the FBD. So FBD is like this is the alpha, this is the beta, and then 50 the angle theta, and then the 60 key, and then this one 94.5. So to solve the value of alpha, we're going to get the 50 square is equals to 60 square plus 94.5 minus 2, 60 times 94.5 cos alpha. So to rearrange this, we're going to write cos alpha is equals to 50 putragis ka sayo po eh. Ano lang. So to rearrange this, we have cos alpha and then 94.5 Okay, to rearrange this one, we have cos alpha 94.5 squared plus 60 squared minus 50 squared, then over 2 94.5 times 60. So therefore, our alpha is to cos negative 1 94.5 square plus 60 square minus 50 square 2 times 94.5 60. This one, so 0.45. So shift cost value of 0.8845 equals to 27.809. Therefore, our alpha, the value of alpha is equals to 27.81 degrees. 27.81 degrees. Okay, so the next we have also in figure 3, which is determine the angle. For this one, we have to determine the angle now with the same figure 3. So in order to find the angle, we need to write the FBD, which is the same as this. So FBD is, this is going to be the alpha, which is 27.81, and then beta, and then this is 50, this is 60, and then 34.5. So in order to get the cosine, in order to get the theta, we need to write 94.5 squared equals to 60 squared plus 94, 50 square minus 2, 60 times 50 cos beta. So in finding beta, cos beta, using the cycle calculation, using cycle, we have cos beta is equals to negative 0.4717. For 0.4717. So we have now the beta, which is 118.145 degrees. So remember that our theta is equivalent to 180 degrees. So 180 degrees. Okay, so for next problem, we have a cylindrical drum 2 meters in radius is held by a rigid bar AB hinged at A and a flexible wire cable BC as shown in the figure 4. The drum weighs 1,500 Newton. Neglect the friction in all contact surface. Which of the following gives the normal reaction at D? So we have two possible question. We have the reaction of D and which of the following most nearly give the tension in cable BC. So first is the reaction of D. So sine 30 degrees is equals to 1,500 Newton RD. So we have RD is equals to 3,000 Newton, simply using the cycle. So the final answer is RD is equals to 3 kilonewton. So next is which of the following most nearly gives the tension in cable BC. So we have tan theta is equals to 3/4. So theta is equals to 36.87. So our alpha is also equals to angle theta minus 30. So 30 minus so angle theta minus 30, which is equals to 6.87. So the summation of MA is equals to 0. So the formula is T BC cos alpha times 40 is equals to reaction B, which is 7.464, and so which is ang atong value sa RD is 3,000 Newton. So 3,000 Newton times 7.464. So overall, RT BC is equals to 2255.39 or Newton, or 22.55 to 55 kilonewton.
So the problem is a 10 kilogram weight is suspended by a rope from a ceiling. If a horizontal force of 5.80 kg is applied to the weight, the rope will make an angle with a vertical equal to, and this if BD. This problem, the solution if this is tangent theta is equal to 5.80 kilogram divided to 10 equals to theta 30.11 degrees.